Today's video is the next video in my series where I wire up my new house for home networking, whole home audio, and various other smart home systems. In my previous video, we ran in an absolute ton of network cables. We can see them all in the rack here. So we've got an absolute ton of Cat6a network cables, speaker cables, and all that sort of stuff. So we've got all these run in. So in this video, we're going to start terminating them. So what we'll do first of all is we'll take a look at a couple of changes I've made since the last video. I've just done a little bit of tidying up and stuff since you last saw this. We'll then take a look at all the accessories we'll be using, all the network faceplates, patch panels, keystone jacks, and all that sort of stuff, talk about what we'll be using to terminate these, and then we'll go around to all the rooms and start terminating the network points. And I'll go into full detail showing how I'm terminating the keystone jacks, how I'm terminating the speaker connections, how I'm installing the faceplates, and kind of do a full in-depth video showing all the terminations. And then in the next video, we'll terminate the rack side of things. My original plan was to do all of this in one video and try and get the rack working in this video, but that is just not going to happen. I'm actually refilming this intro and I'm currently editing the video. It's well over an hour long. I'm not going to be getting the rack set up in this video. So what we'll do is in the next video, we'll then get all the patch panels installed in the rack, get all the active network equipment installed in the rack, and finally get everything operational. So that'll be the next video, but in this video, we're going to get all the stuff set up in all the rooms around the house. So what we'll now do is we'll jump in, we'll take a look at what I've done since the last video, and we'll get on with things. So since that previous video, I've tidied up all the cables where they're going into the rack. So as previously there was a big bundle hanging out the ceiling, what I've now done is I've installed these hooks so the bundle comes down, loops round here, over, and then into the rack. And this just lets me keep a decent amount of slack in the room, out of the rack, neatly up here. Then if I ever needed to move the rack, I can relatively easily unhook it from these hooks, sort of untangle the bundle, and then use the sort of additional slack here to move the rack around the room. This isn't the only slack there is. There's also an absolute ton of cable slack inside the rack that I'll also keep inside the rack there. In hindsight, I possibly could have maybe put some cable basket on the wall and run the slack down and then back up again, but this was a decent enough option and it's easy enough for me to undo to kind of get the slack out if I ever need to. That's all the cables coming down through the fire grommet that we talked about before. This additional white cable that's hanging loose is alarm cable. Eventually I'm going to pull that back up into the ceiling, run it across the ceiling and run it down this wall in steel conduit into the alarm panel. So that's currently here, but that will be moving. The other additional work I've done is I've installed this electrical stuff on this wall here. So what we now have is we've got this steel conduit here. I decided to use steel conduit because it needs to go up through the ceiling, which is a fire barrier. So at least with this as being steel conduit, all I need to do is fill that little gap up there with some sort of fire sealant, and then that's absolutely fine. Whereas if this was plastic conduit or trunking, I would need to get much more sort of higher end sort of conduit gland kind of things, much like I have up here. So something like this cable grommet. I'd have to get something like this up here to seal a sort of flammable pipe like PVC, but with steel conduit I don't need to worry about that. It was an interesting experience doing steel conduit because I've never worked with it before, so it was a lot of money for lots of additional tools to try and thread it all. Definitely a lot of work, but I'm very happy with the end result. So what we now have is steel conduit comes through here. This goes through to the understairs cupboard, so we come through from the understairs cupboard with a cable. That cable comes down the conduit and feeds these additional accessories we have here. So we have a double socket here, which is labelled comms rack only, so this is for the comms rack to connect to, and we have this fuse connection unit here for the alarm panel. And I've gone for a sort of special fuse connection unit here that's designed for alarms, so it does have a switch, but it's a key switch rather than like a normal switch. So I can isolate the alarm panel, but I can't accidentally switch it off, so I've kind of gone for that there. The alarm panel will be a metal alarm panel, so that'll go on the top here, and hopefully I can just attach the alarm panel onto this coupler, so I can just connect it straight onto the steel conduit system. I've also left a decent amount of slack cable sort of hanging out here already connected, so that hopefully when it comes to connecting the alarm panel, I can do all that with the spur isolated and not have to turn off the entire circuit, so that would be quite nice. Then to feed all this, I've installed a dedicated 16 amp RCBO. So my consumer unit is a split load board, unfortunately, and what that means, if people don't understand UK electrics, is there's two RCDs, or GFCIs as Americans would call them, that protect a bunch of different circuits. So if either of those, any circuits on a particular RCD has an earth fault, it'll trip that RCD and knock out all the other circuits on that RCD. That's not ideal. What I'd much rather have is RCBOs, where every circuit has its own RCD, and that way if that circuit has an earth fault or trips off, it only affects that circuit. At some point in the future, I do want to convert the board to be fully RCBO, but at least for now, what I've done is I've installed an RCBO in one of the high integrity ways, which is essentially a way on the consumer unit that isn't protected by either RCD. So that RCBO that has no other upstream RCD protection, so that in itself is a dedicated RCBO feeding all this equipment. That means that no sort of earth fault on any other circuit in the house can affect the comms equipment. So I can trip off any circuit, anything can go wrong, but the comms equipment should stay on. So that's what I've done. All this is fed from a dedicated 16 amp RCBO. So that'll feed the socket feeding the comms rack and the alarm panel. And if in the future I wanted to run anything else off of this, potentially extend it up into the house and run other equipment off the circuit, I definitely could. But right now, that's what we have. We have a double socket to feed the comms rack and a spur for the alarm. The other thing you might have noticed here is that the conduit comes through the wall into this conduit box, but also extends up into the ceiling. So what that is a bonding conductor. And that's because I'm using shielded cable. The Cat6a cable I'm using is shielded, and therefore it needs to be earth bonded. So we'll take a look at this in more detail later in the video, but essentially what I needed to do was run a dedicated bonding conductor from my main earth terminal, which in my case is in my consumer unit, I don't have an external main earth terminal, into the rack, and use that to bond all the patch panels for the Cat6a cabling. Now, the overall information on doing this is a bit vague, but I found some pretty good guidance document from a UK cabling installation company that put out a sort of white paper on the best way to bond structured cabling, so I kind of followed that. So to do that, I've run a 16mm earth bonding conductor from the consumer unit up this trunking. It runs through the ceiling, and then it comes through here, and you can see it's inside this cable bundle. So we have that bonding conductor there. That's a massive 16mm bonding conductor that comes round and then comes down into the rack. We can then see the other end of it here. I've just left all the slack on it. I'll end up cutting this down a little bit. This will then go into a bus bar installed inside the rack, and then all the patch panels along with the rack itself will all bond onto that bus bar. Now, this cable is absolutely huge. It's a 16mm bonding conductor, and it's a big, thick 7-strand cable. In my previous video, someone did comment and actually said, rather than getting this sort of cable, get a tri-rated cable, which would be a lot more flexible. I did try to get that, but it was just going to be a bit too awkward to get. I'd have to either order 100 meters or specifically order a cut length of it. So I thought, well, this is cheap and screw it, I'll pick it up. But in hindsight, I do wish I'd gone for the tri-rated one. It's fine now it's installed, but this is extremely thick and really hard to bend. So definitely, if you have the time and the ability to get a tri-rated cable, it probably is a better option because this is quite thick and unwieldy. But yeah, this will be connected into a bus bar somewhere in the top of the rack. We'll take a look at that in a minute. And then all the patch panels will bond to that to bond all the shielded cable. Then we have all the cables in the back, so all the shielded Cat6a cable, a few regular Cat6 cables for some other things, and then all the speaker cable that all needs to connect up inside the rack. So there you go. That was a look at all the work I've done since the previous video. So what we'll now do is we'll run inside and take a look at all the accessories we'll be using, all the faceplates, patch panels, all that sort of stuff. We'll take a look at those, and then we'll go and actually install everything. So now let's talk about all the hardware we'll be installing. Generally in the UK, for network faceplates, we use what are called Euro modules, which are where you buy a faceplate like this. You then buy different modules like this, representing whatever you want to install. It can be network, it can be things like TV aerials, speakers, loads of different options, and you then clip them into the faceplate, and you can then kind of make up faceplates of whatever you want. So you can have network modules, your TV points, and kind of build up a modular faceplate to install wherever you need it. The other option you can sometimes find for this is you can sometimes find sort of pre-made network faceplates like this. This is a phone point, but it's the same idea, where you kind of get a pre-made accessory that has a module built in. Generally, I tend to avoid these and always go for the modular approach, just because with these you don't really get as much flexibility. You couldn't really have a network point and a TV point on the same plate. If you want to change it over time, you can't really do that. And likewise, these are also generally only available in Cat 5e and Cat 6 variants. If you need things like Cat 6a or you need a shielded network point, you can't really get them in these sorts of ranges usually. So I would always generally go for the modular approach. The other bit of advice I'd give is if you're trying to install a network in a house and you're trying to retrofit and you've already got existing electrical accessories, don't just go out and blindly buy whatever Euro module faceplate you see, whatever the cheapest one is or whatever one a particular shop has. Take a bit of time and try and work out what existing electrical accessories you have and buy the Euro module plates from the same product line. Because even if you've just got basic plain white plastic accessories, there are still going to be a lot of differences between brands. The overall sort of curvature, the overall profile will be different, the colour will be different. Even if they're all white, you get very different shades of white. Some accessories are basically pure white, some of them are almost grey in comparison. So it makes sense to spend a bit of time and try and get plates from the exact same product range. And that just makes everything look a lot neater, a lot more cohesive, and a lot more professionally done than having kind of completely mismatched accessories. It's generally pretty simple to do that. If you sort of got a house that all your electrical accessories are the same, just pop off a socket or a switch and just see if you can find a brand on the back. For example, this one, the light switch I took out of this house that were already installed here that I've replaced. Take it out, take a look on the back, you'll see a brand that says Dita on it there. That's the brand. You look up the Dita website, maybe look up this part number as well. You'd see this is from the Dita Slimline product range, and you can go on that Slimline product range and buy a Euro module plate from this exact same range. And that just means that your network module plates that would be next to potentially existing sockets or switches would have the exact same colour, exact same sort of curvature profile, and just look exactly the same. Now, in this house, I'm actually going to be replacing all these sort of cheap white accessories with nice screwless metal ones. So these are the new ones I'm going for, which are from the Click Definity range. So they're sort of screwless metal, stainless steel sort of accessories. So these are the sockets I've gone for. I've got the switches and all the other accessories. So because of that, for all my network points, I'm going for Euro module plates from the same range. Now, because this is a screwless range, these come in two parts. So you separately need to buy the insert, which is essentially this piece that you would screw to the wall and click all your modules into. And then you separately buy the faceplate, which is a decorative part that'll clip onto the front of that and finish it off. So for most of my network points, that's what I'm going to be using. I'm going to be using these Click Definity ones. I've got them in a mix of 4 module varieties and 2 module varieties, depending on where I'm going to put them in. And this is generally what I'll be using around the house. For places I don't really care about them when I'm not seeing them, so for example behind TVs, inside cupboards, things like that, I'm using accessories from the Click Mode range. So I've got Click Mode sockets, and therefore the Euro module plates are also from the Click Mode range. And it just means that if they're installed side by side, they'll exactly match and have the exact same shape. Whereas in comparison, if you say take one of these Click Mode Euro plates and hold it next to this Dita light switch, you can see it's similar, but there is a different overall profile, and it might not come across on camera, but the Dita one is significantly brighter white than the Click one that's a bit more of a sort of grey colour. So yeah, that's what I'm going to be going for. In places I care about the decorative finish, I'm going to go for the Click Definity range, and in other rooms where I don't really care about, behind TVs, things like that, I'm going to go for the Click Mode range. So that's all the Euro module plates we're going to be using. Now let's take a look at the modules we're going to be using. So first of all, in terms of network modules, the simplest option you would generally go for when it comes to Euro modules is something like this. The one I've sort of put in here, I'll try and take out this plate, where you kind of have an all-in-one module. Now, admittedly, this is a phone module, this isn't network, but the network ones are basically the same, where you have a module with a port on the front and a bunch of punch-down terminals on the back. You connect your cable to it and click it down into the faceplate. But I'm not going to be using ones like this. Instead, I'm going to be using these. These are the exact same things I use in the flat. I've used these for years and I really recommend them. And instead of a sort of module like this, it's all in one, these are what are called Keystone shutters. So there's no network module in this. Instead, you use a Keystone module, you put it on the cable, we'll take a look at that in a second, that clicks into the back here, and then this is what goes into the Euro module faceplate. And what's great with this is it gives you an angled port. So whereas with this, the port sticks straight out, so if you plug a cable in, it's going to stick straight out from the wall. With this, the cable will slope down from the wall at an angle, and that's absolutely brilliant, because it means, for example, behind the TV or behind a bit of furniture, the cable's a lot neater, it doesn't stick out. Even under a desk, if you're potentially going to kick the cable, it's nice having the cable running down straight in line with the wall rather than sticking straight out, and it's much easier to get caught. So these are great. So these are from XL. Now, every time I show these in videos, people ask where they can get them. You can generally get these from most decent sort of electrical wholesalers that do networking hardware. That's the part number there, so 100-175. But these are fairly specific to probably the UK. With all these kind of accessories and faceplates, they're generally based on your country's electrical system. So these are all sort of designed for the UK's electrical system, our electrical boxes and things like that. If you're in the US, you have completely different shaped electrical boxes, so none of these accessories will fit. In Europe, the electrical boxes are differently shaped, so these faceplates won't fit. Euro modules, these probably should fit your faceplates, but it really depends. So if you're in the UK, you would definitely be able to use all these accessories. But if you're in other countries, you're going to have to really find out what your country uses for electrical accessories and kind of go with what's available. You wouldn't really be able to install these everywhere in the world. But yeah, these are the Keystone shutters we're going to be using. So these will click into the faceplates. I've got a mix of black ones to go with the stainless steel accessories and white ones to go with the Click Mode white accessories. And obviously with these, we need to put Keystone jacks in the back. So for that, I've got these. And these are XL toolless Keystone jacks. So these are shielded Keystone jacks for Cat6a cable, because I'm using shielded Cat6a, or at least FTP Cat6a. And these are toolless. So what you do is you take the cable, you feed the cable through this little guide, you bend over all the wires into the guide and sort of place them in here. We'll do a full demonstration installing one of these later. You cut off the excess, you then have a cable in this guide, you push this into the back of the jack, getting it the right way around. It is keyed, so you can only do it the right way, like that. And then once it's in there, you just click this shut, and when you clip it shut, it'll punch all the wires down and make the connection. Once that's done, you just take the Keystone shutter, click it in like that, And with that, you now have a network module that can be installed into the Euro module plate on the wall, like that. So with these Keystone jacks, these are the ones I've gone for these, which are Cat6a low profile ones. The low profile ones were a little bit more expensive, but for the faceplates like this, I've gone for low profile jacks just to give a bit more space in the back box, because it will get quite tight and the Cat6a cable is very stiff, so the low profile modules just give a bit more space. That's also the other benefit with these angled modules, is because as you can see, the Keystone jack angles slightly up and all my cables are going to be coming down into the back box. So having this angle here means the cable doesn't need to bend nearly as tightly when it's coming into the module. So yeah, these are a really, really good option. The other thing that's important to bear in mind when you're doing this sort of thing is to buy Keystone modules or Euro modules that are the same category as the cable you're using. So if, for example, you've got Cat6a cable like I have here, buy Cat6a modules. If you've got Cat6 cable, buy Cat6 modules. If you're using Cat5e cable, buy Cat5e modules. Don't go running Cat6 or Cat6a cable and then cheaping out and using a Cat5e module because it's just a connector. Because there are differences between them, and technically speaking, if you've used Cat6a cable and terminated into a Cat5e Keystone, you've got a Cat5e link. It would be regarded as at the lowest category of part in that chain. So make sure you are matching the modules to the cable you're using. Likewise, if you've got shielded cable, you're going to need shielded modules. If you're not using shielded cable, you don't need shielded modules. You've got to be careful. And also avoid any modules that don't mention a category, especially with faceplates like this, sort of all-in-one faceplates. Quite a lot of them are bad for just advertising a RJ45 faceplate or a network faceplate, and they don't even give you the category. And at that point, you don't really know what you're getting. It's probably Cat5e, maybe Cat6 at a push. So make sure you're buying modules of the right category for what you're planning on installing. And also with this sort of thing, it's worth sticking to reputable brands. So company brands like Excel, they're always good. Click. Generally stick to the good brands of electrical accessories and network modules and faceplates. Avoid the really cheap Amazon special brands because you just don't know what the quality is, you don't know what the certification is in terms of the category. Is it a true Cat6a module or is it a rebadged Cat5e module? You just don't know. So with this sort of thing, don't cheap out, stick with the reputable brands and you'll generally have a much more sort of frustration-free experience with this sort of thing. So yeah, that's all the modules. So that's network modules out of the way. Of course, we also have other modules. So what we also have that's going to be in quite a lot of the rooms are TV aerial modules. So these are just coax modules, which we can connect to the TV's aerial. So the coax can come down into here. These are quite nice ones that you unscrew it, they open up, the coax kind of goes in, it all closes up like a sort of butterfly module. You get cheaper ones that are just a bare PCB on the back, but these are a bit of a nicer overall option. So yep, these are going to be used for all the TV aerials. Then for some of the speaker connections, not all of them, but in particular for the rear channel speakers that are going to go behind the living room couch and also a subwoofer connection in the kitchen, I've got these speaker binding posts. So again, these will go into faceplate. We can connect the speaker wire that's running through the house onto the back of this, and then on the front you can get either plug a banana plug in there, or you can unscrew the binding post and just put bare wire in that to connect the speakers up. They're color coded red and black, so you'll have one of these for each speaker, and you'll connect both the wires out the speaker wire onto each of these. So we're going to use those for speakers. And then the final type of module we'll be using will be for the subwoofer in the living room. So if you've seen my previous video, I ran a piece of CT100 coax from behind the TV to behind the couch, and that's going to be used to carry the subwoofer. Now the sub uses an RCA connection, so I have an RCA Euro module. And what's really nice with this one is it actually has an F connector on the back. So I'm using regular coax to run that cable because it's a long distance. So with this having an F connector, I can actually crimp an F plug onto that coax and actually screw it onto this and get a really good connection. A lot of RCA modules either just have an RCA connector on the back or just some sort of screw terminal or solder tab. So this is actually quite a nice module that you can actually screw an F plug onto the back. I bought this from CPC along with these ones, so if you're trying to find these are available from CPC. I think the brand's Antiference, I think. Yeah, it's the Antiference 75 series MW773BLKB. They're available in all different colours, so yeah, that's a really good little module, so be interested to try that out. But yeah, that's all the Euro modules we'll be using. The final accessories we're going to talk about is what we're going to be doing behind the living room TV. If you've seen my earlier videos, you'll have seen that I had one of these behind the living room TV, which is known as like a media panel or a lounge plate, they're sometimes called. And if you've got a new build house in the UK, you've probably got one of these. In fact, it's probably the exact same one. And personally, I'm not a huge fan of these. I just find them quite clunky and inconvenient. But essentially what you've got is a double socket or two double sockets and then a bunch of Euro module plates on the same plate, and then you have a back box behind it that's kind of separated down the middle to separate the mains from the low voltage side of things. And they do work, but they're just very big and bulky. And unlike all the sort of standard electrical accessories like these that are standard sizes, so you can swap out different models on the same back boxes, with these media panels, they're kind of proprietary. So the back box that's in the wall is proprietary to the media panel that you've got. So if you want to swap out, you've got to change the back box, and they're all different shapes and sizes. So originally I wanted to swap this out for a nicer looking decorative one, and I was going to go for a Click one. Now, Click don't do one from the Click Definity range, they don't do a screwless one, but they do one in their Click Deco range, which is very similar sort of brushed finish. It's just a bit thicker and it's got a screwed faceplate in it instead of a screwless one. However, unfortunately, the Click Deco media panel is a bit smaller than this one. It's quite a bit narrower. And the problem is that if I were to swap this one out for that one, the Click one wouldn't cover the hole in the wall that's left by this one. So of course I could install that, but then I would need to try and patch the plasterboard up the side to try and make the hole smaller, and that would just be a complete pain. And to be honest, if I was going to start patching plasterboard and do all that kind of stuff, I'd rather just get rid of the media panel, fill in the plasterboard, and instead cut out 4 discrete back boxes and have, for example, a single double socket and then 4 modular panels, because that would be much more useful than having 4 sockets behind the TV. So yeah, I'll probably end up doing something like that in the future. But for now, what I've done is I went out on eBay and I was able to pick up a Dita media panel in a stainless steel finish. These are normally about 80 odd pounds, and I wasn't really going to spend that just to swap this out as almost a temporary measure before I do a proper job patching the plasterboard. But someone was selling this on eBay, brand new in box, for I think £25. So yes, it won't perfectly match all the other accessories or the sockets from the other range. They aren't a complete match, but to be honest, they're close enough, and for £25, this is a decent sort of solution, because I can easily take the plastic one off, take this one, keep the same back box, same cutout in the wall, put that on, and it's the exact same size as the one I've taken off, so it'll cover the hole in the wall. So that's what we're going to do for the living room. We're going to swap out the plastic media panel for the stainless steel one and have all the modules in here basically the same. This one came with a bunch of modules pre-installed. Of course, we'll lose all these because that's designed for a sort of quadplex TV distribution system you'd have in a flat, which obviously I don't have here. A TV return connection again for that sort of system in the flat, and then a phone point that I'm definitely not going to use. But yeah, that's going to come out, and we'll put in, well, this one's going to come out, we're going to put this in, take these modules out and put our modules in, and make it a network faceplate. So that's the old media panel, that's new media panel going in, and yeah, so that's what we'll have. So in this, what we'll do is we'll have my 4 Cat6a modules, so we'll have 4 network modules in here. The TV aerial module will also go into here, so we'll have TV aerial module, and then the subwoofer module will also go into this. So that's all the network modules and things behind the TV, but we've also got all the speaker connections as well. So behind the TV, I have 6 different speaker connections. I have the speaker connections to the 2 rear channels, speaker connections to the 2 ceiling speakers, and then a stereo speaker connections of 2 speaker cables coming from the rack to behind the TV. And those are going to feed into an automatic speaker switch to switch the ceiling speakers between Atmos speakers and then speakers fed from the central audio distribution system. But essentially, we'll do that in another video, we'll go into more detail on that. But basically, I need to terminate 6 speaker connections behind the TV. Now, I could do it with these modules here. If I use these 2 binding post modules, I'd actually need 2 Euro module faceplates to fit them all in. You can get these with 3 binding posts, and then that would fit onto a single plate like this. But what you can end up with there is it can get a bit messy because you've got a bunch of different wires and you can plug them into the wrong ones or get them all mixed up. It's absolutely fine. But I thought I'd try something a little bit different just to see how it goes, because it's not something that's very common in domestic settings, but it could be an interesting option. And I'm going to be trying out Speakon connectors. So if you work in any kind of live sound or professional audio setting, you'll be very familiar with Speakon connectors. They're these connectors here. They're used a lot on sort of professional amplifiers, high-end speakers, things like that, used for sort of PA systems. You've got these speakers here, these speaker connectors here, these plugs. The plugs will go into the connectors, they lock on. And what's useful with these Speakon connectors is they're actually 4-pole. So with one of these connectors, I can actually connect 2 speakers. So I can connect a stereo pair of speakers through one connector. So what it means is, rather than having a bunch of different binding posts all kind of labelled up as what speakers they're for and which pair of binding posts I would need to use, I can just have a Speakon connector, and that would be ceiling speakers or rear channel or from rack. 3 of these Speakon connectors make up cables to connect from Speakon plugs into my AV receiver, and then they can just plug in like that. So we'll try this out, see how it goes. Now I need to obviously put this on some sort of plate to mount behind the TV. You can get Speakon Euro modules, but they tend to take up a double module space, so they take up quite a lot of room. So instead, what I've got to try out is this plate here, which is designed to mount these in a wall plate. Now, Annoyingly, this one turned up pre-scratched. I think someone's opened a carton with a knife and scratched this one out of the box, which is great. So I might need to send that back and try and change it. But you've got this module, this plate here. So what you do is take out the Speakon connectors, put them behind, put some screws through here, across all three modules, and then you screw these into the faceplate, wire the speaker wires into the back, and then on the wall that's just going to give me 3 Speakon connectors that I can plug into my AV receiver. Be an interesting option to try out. I'll also be using a Speakon patch panel in the rack. That's probably a bit more useful than doing it in the living room, but I thought I'd try this out and see how it goes. Now this plate here is kind of a fairly industrial silver, it's almost like a metal clad accessory. It was just the only one that CPC had, but you can get these in other finishes, for example just a plain white one that would probably look better against a white wall. I mean I might even just try and take this and spray paint it white and see if that helps because it's scratched anyway, so yeah, that's what we're going to put behind the living room TV for all the speakers. We have 3 Speakon connectors like that in this plate. So now let's talk about what we'll be installing at the rack. So of course we're going to have to terminate all network cables, so we're going to need patch panels. Now with patch panels you get 2 different types. You get the ones where it's kind of a fixed patch panel where you've got the main bar with all the connectors already on the front, you flip it over and you can punch all the connectors down onto the IDC punch down connections on the back. Those do work, but I'm not a huge fan of them. They are a cheaper option, but the problem with those is they're not very flexible. You've kind of got to punch things all down onto one big bar with all these cables hanging out of it, so they're not that easy to use. And then you can't really rearrange them or adjust them in the future. They're just not as flexible. So instead I prefer to use these, which are called Keystone patch panels. And they're a bit more of a modular system. So instead of punching all the cables down straight onto the back onto built-in connectors, with these, you terminate all your cable runs into Keystone jacks, much like we're doing at the faceplates, and then the Keystone jacks clip into this patch panel like that. So we've got the patch panel there, we've got 3 of these, and then we have the Keystone jacks. So these are very similar Keystone jacks to what I'm using in the rooms. The only difference is as I mentioned, the ones I'm putting in the rooms are low profile models. The low profile ones are a little bit more expensive than the standard ones, and I don't need low profile for the patch panel. So for the patch panel, I've got these Keystone modules here, which are again XL Cat6A Keystone modules. They're just the non-low profile version, so they're slightly longer. It won't make a difference at the patch panel, but it's just nicer to have the low profile ones fit in a tight back box. So all the runs to the patch panel are going to terminate into these Keystones, which are again toolless termination. So what we can do with these, we can take these modules, take the patch panel, the module will then clip, terminate the cable into the module will then clip into the patch panel like that, and then you've got the Keystone jack on the front of the patch panel, and then we can label them all up. The other thing that's going to be good with this is, whereas a lot of the time with networks what you'll end up doing is just punching all the cables down to the patch panels in order, and then when you number all the ports in the rooms, you'll kind of number them with a designation that defines which patch panel it is and then which port on the patch panel that port's linked to. With this install I'm going to try something a little bit different just to kind of see how I like it. Whereas instead of doing that, I'm going to kind of number the ports based on the room they're in. For example, if the port's in the living room, I'll label it LR01, LR02. If it's in, say, bedroom 3, it'll be labels like B3-01 and so on. And it just means that at the patch panel end, I can very easily see which room a port refers to. Because in my flat, they were all just numbered based on the ports in the patch panel. And it worked, but it did make it a bit of a pain to think, right, what's in that room? It'll just make it easier to kind of locate a port if you know what room it's in. It also means that if I add additional ports to a room in the future, I can kind of keep the numbering consecutive. So if the living room goes up to LR-06, the next port in the living room can be LR-07. Whereas if they're all punched down into a patch panel in order, and then I say I had 24 ports and they needed to add another one to the living room, that next port would say port 25. So you'd have the ports in the living room would be like 1, 2, 3, 4, 25, which would bug me. So I'm going to try that and see how I get on. So with these patch panels, what I'm going to do is I'm going to put all the ports kind of grouped by room. So say I have the living room ports, a couple of blanks, then say the bedroom 1 ports, a couple of blanks, bedroom 2 port, a couple of blanks. And what that means, if I ever want to add more ports into the room in the future, I can take the blanks out, put additional modules in, and keep all the ports grouped together on the patch panels based on what room they connect to. So we'll see how I get on with that. Just an idea I had on how I want to try this out. So we'll see how we get on. So yep, that's the patch panels we've got there. And then with these patch panels, I've also got a cable management bar. And this is something I would say, if you're going for patch panels, always get ones that have some sort of cable management bar at the back. It's interesting this one folds out, I haven't actually looked at this yet. But yeah, these fold out like that at the back. This will then clip onto the patch panel through a little hook there. You need to figure out exactly how it goes on, but these will clip onto the patch panel. And then when you terminate all your cables into the patch panel, you can then zip tie all the cables onto this bar. And that just means that you end up having a bit more strength, nothing's going to accidentally pull out and things like that. So I would definitely recommend getting a patch panel that has this sort of bar at the back to retain the cables. There we go, that's it slotted in like that, so that slots in there and goes like that. And what's also nice with this patch panel is the numbering isn't fixed, it's actually little bits of paper that are behind a plastic shield that can come off. So when I do want to label these up with different sort of labels, rather than just having sort of consecutive numbers, I can actually pop this off and put a label in under there, rather than just having a label stuck on the front. So yeah, that should be nice there, so that's some patch panels. Now, the other thing you'll notice with these patch panels is they have this big grounding cable hanging off the back. And that's because these are shielded patch panels. And that's something important. If you're using shielded cable, not only do you need shielded Keystone jacks, but you also need to have a shielded patch panel. If you just use shielded Keystone jacks in a normal patch panel, you can't then bond the Keystone jacks to ground. So with a shielded patch panel, what you have is all the Keystone jacks will clip into this metal plate here, which then has this bonding conductor on it, and that bonding conductor can then be grounded. So obviously earlier we talked about how I've run that big 16mm bonding conductor into the rack. That essentially will need to connect to all of these patch panels through these little fly leads that have a crimp connector sort of pre-attached. So how do we do that? Well, what we're going to need is an earthing bus bar. So here's one I've got here. This was from a place called Netseed, which is a really good sort of wholesaler for networking hardware. If you're looking for networking hardware, Netseed, they are really good. They've got a huge range. So I bought this from Netseed, and this is a 1U patch panel, a 1U bus bar. So essentially it screws into the rack, and it's this big copper bus bar with a bunch of screw connections that all the bonding conductors can be attached to. So all the patch panels have these existing fly leads. These can easily already be attached onto these terminals. My big 16mm bonding conductor I'm pulling in, I'll need to crimp a connector onto the end of that to crimp on, and then that can attach to this. It comes with these additional fly leads as well that I could use, for example, to go from the bus bar onto the rack itself. So I'll be installing this in the rack and use that to bond all the patch panels to ground. Now, of course, if you're not using any shielded cable, you don't need to do any of this. And it's a bit of advice, if you are running a network and you don't need shielded cable, don't run it unnecessarily. Because as soon as you use shielded cable, you have to deal with all of this sort of stuff to ground the shield. You're much better just running unshielded cable because then you don't need to think about this or do any of this. Because I'm running Cat6A cable, generally speaking with Cat6A, you do start to need to go shielded. You can get unshielded Cat6A, but the problem is because with that you're relying on the twists alone to prevent crosstalk. The cable's twisted really tightly. It's really quite stiff cable, it's really awkward to untwist because it's so tightly twisted. It's just generally not the best option. So with Cat6A, generally speaking, you do end up going to FTP cable, which is where there isn't an overall shield, but each pair is individually shielded from the others, which is what I've got here. And because it has that shield needs to be bonded to ground. Especially if you look at the cable I've got and take it apart, you'll notice that it isn't twisted nearly as tightly as even regular Cat6, and that's because it's relying on that shielding around each pair to prevent crosstalk a bit, so therefore it's not relying on the twisting as much, so it's not twisted nearly as tightly. Therefore, if you weren't to ground that shield, the actual twists aren't as tight, so you're not going to really get that sort of performance. This shield needs to be grounded, so that's all what we're having to deal with here. So yeah, this is how we're going to be doing it, but yeah, if you don't need shielded cable, don't buy it unnecessarily because it's a lot of additional work to deal with, but yeah. Bus bar will go into the rack, that's going to be bonded to ground, and then all the patch panels will connect up to this bus bar. The final thing we're going to need to terminate at the rack is all the speaker cables. And once again, we're going to use a patch panel. So as I'm going to also do in the living room, I'm going to use Speakon connectors. So what I've done is I've got this patch panel here. This is, I think it's known as like a D universal type connector. So this is a sort of standard of connector used in the AV industry for things like XLR jacks, Speakon connectors and things like that. And this is a patch panel for those connectors. So these Speakon modules comply with that standard so they can fit into there. You'll put a screw through the front with a little nut on the back and fix all the Speakon connectors into this patch panel. You can get other modules for this, you can even get network modules if you wanted, or XLR connectors, F plugs, all that kind of stuff for these sort of patch panels, but we're just going to use Speakon connectors. So I've got this 12 module patch panel here, all the Speakons will go into that, and I'll have a Speakon connector for each room. So if a room has stereo speakers, the Speakon connector will carry both left and right. If it only has a mono speaker, the Speakon connector will just carry the single channel. So it means that I don't need to worry about all different wires for each speaker, I'll just have one cable per room. And when I label the patch panel up, there's a little bit here you can take off and put a label behind. I'll possibly put some sort of little designation on that to define whether it's a mono zone or a stereo zone. And then I'll make up Speakon patch leads that will go from this patch panel down into the amplifiers. Now, of course, all that audio stuff is going to be done in a future video. So in this video, all I'm going to do is get all the speaker cables terminated into this patch panel. Now, the only other advice I would say if you're doing this is just something I found out just while buying this patch panel that isn't completely obvious, is when you're buying these sort of D-connector type patch panels, you need to watch the spacing between the modules if you're using Speakon connectors. So this one here has 12 modules, and with that you can fill all of these up and use Speakon connectors absolutely fine. But with these you can also get ones that I think have 16 modules in them, and therefore they're spaced a bit closer together. Those are fine for XLR connectors, but with Speakon connectors, apparently, I haven't tested this, but apparently they're then too close together for the Speakon plug to sort of operate without catching. So if you're buying these, don't just sort of go, oh, the 16 module one has more modules, I'll buy that. If you're using Speakon connectors, you need one that has a decent amount of space between each module. So the 12 module one made more sense. The same also applies to these kind of faceplates like this. The 3 module one is fine for Speakon connectors, but the 4 module one apparently won't fit Speakon connectors because they're too close together. So just something to bear in mind there is the spacing on these can be an issue if you're using Speakon connectors, but this 12 module one will be absolutely fine. So that's all the hardware we're going to be installing. Now, I'm not going to film installing every run because there's 72 runs. That's an unreasonable amount of network connection I'm going to have to terminate. I'm not looking forward to doing this. It's going to take ages. So instead what I'm going to do is I'm going to run away off camera, start terminating all the runs, and I'll kind of jump in and film maybe one of each type of termination. So I'll terminate one of the Keystones on camera, one of the Speakon connectors on camera, do the patch panels on camera, that sort of thing. So time to run away, terminate a completely unreasonable amount of network runs, and we'll jump in and see how I'm getting on. Okay, so I've been running around terminating various points, so I thought I would do a dedicated part of the video where I just show exactly how I terminate one of these network runs fully end to end. So here I am in one of the upstairs bedrooms, and we've got the 2 cables sticking out a hole in the wall. Now, as you can see, there's an absolute ton of slack here. I could obviously cut that off shorter because that would be far too much slack just to push up into the wall. However, I still have access for every network run to above the network run, so this is upstairs, so I can just go up into the attic and access above here. And for all the downstairs runs, I've still got access to all the holes in the floor. So what I'm going to do instead with all of these runs is I'm going to terminate them with all the slack still there, and then I'll go above and pull all of the slack back up above the ceiling, so either into the attic or above the upstairs or under the upstairs floor. That then means that in the future, if I ever need to access any additional slack, there's loads of slack there that can be pulled down. So what I'll be doing is I'll be terminating these with an absolute ton of slack on it, and then pulling that slack up into the attic. If you didn't have access to do that, you would generally need to cut this a little bit shorter because you would never be able to push this much slack up into the wall without it all kinking horribly. But I'll be terminating with all that slack. So I'll probably cut these off to be the exact same length as each other because currently they're a bit different, but all the slack will be pulled up into the wall. So we see we have these 2 runs here, labelled 19 and 20. This is a sort of temporary numbering system I did just when I pulled the runs in, and I've got a spreadsheet that tracks all of these numbers. As I mentioned earlier, I'm going to be labelling these with a designation that defines what room they're in. For example, these 2 runs here will be B2-04 and B2-05. That's bedroom 2 port 4 and bedroom 2 port 5. So that's the sort of final designation these runs are going to have. So in my spreadsheet I'm tracking 19 is the original designation, that's the final designation, and they're all sort of tracked in a spreadsheet so I know what they're all going to be called. So yeah, time to terminate these. So the first thing I need to do is install the back box. So for these I'm just using these standard dry lining boxes. There's a few runs where I'll need to use a metal box just because there's a wooden batten across the back for a neighbouring socket, but anywhere there's not any kind of batten in the back, I'm just using a dry lining box. And I'm using the 47mm ones. You could definitely fit this into a shallower box, but there's absolutely no point. I think a deeper box costs like 10 pence more, if that. It makes sense to just use as deep a box as you can just to get all the room you could possibly want to work with. So all you do is only knock out the little knockout in the top of the box, put that in the wall and get the cables through it. Now for a single gang box like this with a pair of network modules in it, the existing cutout in the top is perfectly fine for feeding the cables through and getting them into the modules. However, when it comes to a 2-gang box for say 4 modules like I'm doing behind the TVs, getting all the cables through this and bending them into the modules isn't going to work. So I'll demonstrate one of those after this because I've got an interesting trick. I've got a trick up my sleeve to sort of get that to work. So yeah, we'll take a look at that in a minute. But yep, time to get this box into the wall and start terminating this run. Okay, so I'm going to cut these off the same length and I've installed the back box up there, so we're now ready to go. So the first thing we're going to need to do is strip the cable back. So you can get special tools to sort of strip Cat6 or whatever. I've not got any of those. I'm just going to use this sort of standard wire strip to use for things like Flex. I think I got this in like Lidl or something years ago, but it actually works really well. Similar idea to think like the Nipex Ergo strip sort of thing. So what we need to do is we need to strip the outer insulation off. Now for this, no matter what tool you're using to strip any kind of cable back, especially things like data cables, you're not trying to cut through the outer insulation. All you want to do is just score it, and then you want to snap the outer insulation off. If you try and cut deep enough to cut all the way through it, you'll almost certainly nick an inner core, and with these solid core cables, as soon as you even slightly nick one of the inner cores, it'll snap off when you start bending it around to terminate. And then you usually won't notice it snapped off until afterwards and you wonder why your connection isn't working. So to strip this, all we're going to do is we're going to line it up sort of wherever I want to sort of line up in there. You want to take a good amount off. The more you have, you can give you more slack to work with and kind of bend around. And especially with these shielded cables, because of what you need to do with the shield and the drain wire to connect these jacks up, you do want to take off a reasonable bit of insulation. So probably about that much. Just going to go around like that. And all I've done there is, as you can see, I've just put a very light score into the insulation. You might not even be able to see the score there. But with that little score in, if I bend it, it'll snap like that. And you kind of want to hear a satisfying snap noise. You don't want it sort of just to pull straight off, because that would indicate you maybe cut too deep. But that very much snapped there, so that will now pull off like that. And we have all the inner cores. So now here we see the inside of the cable. And as I mentioned earlier, this is Cat6A, but this is U/FTP Cat6A. What that means is there's no overall foil shield around the cable, but each individual pair has its own foil shield. So as you can see, if you pull these back, each pair is isolated in its own shield to protect it from crosstalk. And unlike regular Cat6 or UUTP Cat6A, there's no inner plastic separator here to separate the individual pairs because it's all done by that foil. So it's a little bit different construction to sort of standard Cat6 you're probably used to, but that's what we're working with here. So we have the foil on each of the individual pairs, and we also have this drain wire which is used for the ground connection. So we're going to put the drain wire off to the side, and we need to remove this foil. Now I'm following the official instructions for these particular jacks from XL. There will be slight different variation between different brands of jacks, different models, how you're to terminate these. So this is how you're meant to terminate this particular model of jack I've gone for. So what we need to do is we first will need to take the foil on one of the pairs, doesn't matter which one, and pull it back, and then wrap it around the outer jacket of the main cable. So if I get that there, find the outer foil like that, I want to unwrap it like that, and pull that foil back. So pull it all the way back there like that, and then we want to flatten it out. So get that nice and flat. Like that. It's a bit kind of hard to get in with the camera angles because the cable's kind of tied into the wall, but you get that sort of flattened out like that. What we then want to do is fold this foil in half lengthwise, like that. And then with that foil folded sort of tightly in half, we want to take that foil and wrap it around the outer jacket of the cable. So keep the drain wire out of the way, and we want this to wrap around the outer jacket of the cable. This probably won't be the neatest termination I could possibly do because it's very hard to do these things leaning over a camera, but that's it there. So that's now wrapped around the outer jacket of the cable. We'll tighten it up again later. Then what we need to do is just remove the foil from all the other pairs. So to do that, the best way I found to do it is just literally snip somewhere very close to the bottom of the foil. So where it's folded back, you just want to put a very, very slight nick in it. Also being careful that you never go near any of the inner cores. You also want to use a decent pair of good sharp flush cutters to do this. And then once that little nick's in there, it'll just tear off around the pair. So do that to all the others. Find the edge that we can sort of safely nick, like that. Snip it and tear it off. So I'll do that to the others, and then we'll come back. So that's the foil now removed from all the pairs. So what we now need to do is put the little guide on. So we've got the little guide that comes with the toolless Cat6A jack. This needs to go over all the wires, but not the drain wire. So we want to keep the drain wire out the back, and then feed all the other wires, all the pairs, through the middle. And then kind of push this all the way up, so right up towards the back of the cable. You'll see on the side of the guide there's a little slot, there's one on each side. We want the drain wire, which is this one here, to come out of that little slot there, like that. So the drain wire sticking out there. So what we now need to do is get all these wires into the guide. So as you can see, we've got this little guide printed on the side of this little colour code printed on the side of the guide. That's what we want to match up. As you can all see with this, there's two different colour standards. There's the A standard and the B standard. I think there's regional differences as to what standards are more common. In the UK, generally speaking, we always use the B standard, so we're going to stick with the colours that are on the bottom of the guide, not the top. If you're installing an existing property that already has some sort of network installation, generally match whatever standard has been used there. You know, if you've got a place that's already wired in the A standard, it's better to stick with that than to use the B standard because that can cause confusion. But if you've not got any network already installed, like I don't have here, generally I would go with the B standard. So that's the colours on the bottom of the guide. So that's going to be orange, white, orange, brown, white, brown, green, white, green, and blue, white, blue. So at this point, what we now need to do is get each of these pairs pushed down into the guide, so just lined up into the little holes inside the guide. Of course, you don't want to untwist far too much here, but equally with these Keystone jacks, there's not even that much room to untwist, so just generally get the wires neatly laid down into the guide. Don't be too over the top about not untwisting too much and end up sort of kinking them because you don't want to untwist a little bit. Just get them laid in nice and neatly, so they're not untwisted too far, but also not all bunched up. So what we'll do is we'll get these all lined up, and then we'll come back. So there you go, that's all now the wires pulled in and lined up with the guide, so you can see the colours are all matched on the side there. It's really just potluck as how nicely this lines up. Sometimes when you do it, the wires come out the cable in the perfect order and they're perfectly lined up with all the individual colours, so you can just go fold them straight over. Sometimes you do have to cross them over. It just depends how all the wires are the pairs are twisted around each other in the cable at what order and where you've cut the cable will just sort of define where they come out. But yep, that's them all pushed into the guide there, neatly pulled out to the side, all sort of straight and, you know, not bunched up or anything. So what we now need to do is cut these all off flush with the edge of the connector, and then we can put the jack together. So obviously that's now there, we now need to cut them all off. What I find is before you cut these off, if they're sitting outside the connector here and they're not twisted together, just twisting them together, or even just one or two twists, really stops them pinging miles away. And I would definitely say keep some sort of thing here to collect all these and put them and tidy them up as you go, because these little bits of wire just end up getting everywhere. I remember in my flat I cabled that I think 6.5 years before I moved out, and even when I was moving out I was still finding little bits of wire sort of caught down the sides of carpets and stuff because these bits just get everywhere. So now all you want to do is cut these off completely flush with the edge of the connector. And you want to use a good pair of flush cutters. Don't use some sort of diamond shaped cutter like this that'll cut an angled edge. You want to use proper flush cutters and cut it completely flush with the edge of the connector. So then snip all those off. Also before you do this, you want to double and triple check the colour code is definitely correct. So green, blue, white, blue, white, orange, orange, white, brown, brown. And also when you do check the colour code, make sure you're actually checking the colour code and don't do what I've done sometimes and read along the colours going, yep, there's all the colours, and not actually check what wires are in the right colour. It's very easy to kind of get complacent if you do this so often. So now they're all lined up, ready to put the jack together. Now the final thing we need to do is we need to connect this drain wire so that the shield is also connected to the jack. So for this particular type of connector here, which is the low profile version, it's different on the non-low profile ones, we need to wrap the drain wire around this plastic collar at the back of the connector. So wrap that around there and kind of fold it in neatly at the end. And now that's folded in there, we can now put the connector together. So on this body, there's a couple of little arrows printed on it, so we need to line up the arrows with the outer connector, line that all up, push it in there, with it lined up, then close the connector body and just squeeze it shut. If we do that, that will all connect down, punch down and make the connection. It won't necessarily always click in perfectly just because it's a little bit stiff. So what you can then do is just use a pair of pliers and just sort of give it the final squeeze just to get the final connection there to get it all to clip in nicely. Nice solid click there, that's the jack all assembled. So now we have a finished jack. So now that's the jack all assembled, at this point I like to do some very basic initial tests. Of course there isn't actually another connector on the other end of this cable, and to do all the final tests what you really need to do is have a connector on each end and do a full wire map test and continuity test through the cable. But at this point I like to do a simple test, and that's using this tester here, which I made a video of previously, which is the Nofia NF8209S. This is a really cheap, inexpensive little tester, but what's really good with this is that not only does it do continuity tests, it also does a length test, where it'll measure the length of each individual pair, even when there's nothing connected to the other end. So what we can do with this is we can plug it into this cable even though the other end isn't terminated, go into here, run the length test, doesn't matter what type you pick, just start test, and that'll tell me the length of each pair in the cable. And as we can see, each pair is 18.8 meters. and that means that this cable, this jack, should be connected correctly. This won't check that the wires are in the right colours, but what it will do is it'll at least check that all the wires are crimped down correctly, none of the wires are sort of loosely crimped. If any of these hadn't punched down correctly, what you get is you get 0 meters for one of the pairs. So the fact that all the pairs are showing the same distance indicates that generally speaking this jack should be connected properly. Of course this isn't a complete test, we'll need to do that later, but at least for now that gives me decent confidence that this jack should be crimped well enough. So that's checked all the individual pairs. The only thing it hasn't checked is the continuity of the shield, but we can test that with a simple continuity tester. So what we'll do is we're going to test between the bit of the shield that's sticking out the back of the connector and then the outer body of the connector, which will be grounded via the drain wire. And as you can see, we get continuity between those two. So that indicates that the shield is correctly connected to the jack. Now later in the video we'll do a proper test with it all, and not only am I using this cheap little tester here, I've also bought a proper, albeit very old, network cable certifier to do full certification of all these cables, and I'll be showing that in a dedicated video. But for now, this little cheap tester just lets me quickly check that each cable is connected correctly. So yeah, that's that jack done. Time to do the other one, and then we get the faceplate on the wall. Oh, and one final thing to do before I start terminating the other one is I need to label this up, because obviously I had the original number designations, which first of all are changing and second of all are being cut off the cable. So what I've done is I've printed off the final designations on a cable wrap label. So I've used my brother label maker to print off one of these labels, which I can peel off and I can stick on the side of the cable there and wrap around it. So all these cables are going to be labelled inside the wall and on the front of the jack. So if the front faceplate's ever taken off, you can still see the label designation. So that's labelled there. I've got a label for the other one as well. So yeah, now time to terminate this. Okay, so that's now both connectors on and labelled. At this point you'd probably want to go away and terminate the patch panel end and then test the cable before you screw it all back to the wall. But just because I'm demonstrating this all on camera for the single run, I'll do it fully, complete it off, get the faceplate on and everything like that at this point. So as we mentioned, we're going to be installing the Euromodule faceplate, so we need to install these Keystone shutters. So we're going to be using the black ones here because it's going with the stainless steel faceplates. So what we need to do is we need to line up the bit where it says up on both the shutter and the Keystone jack itself, get those both lined up and click it in. Do the same on the other one. So get the up aligned and clip it in. So now that's in there, we can check we've got the jack visible there. The thing with these is you can easily put the connector in the other way around, it'll clip in perfectly fine, but then won't line up at the front, so it's worth definitely checking that you've definitely put it in the right way, because that's an easy mistake to make. Now what we need to do is get the insert out for the Euromodule plate, so get that there. Again, line the correct way up and click these in. So put number 5 on the right hand side and put number 4 on the left hand side. So get that pushed through like that. There we go. That's them both now in the faceplate. So as I mentioned, at this point I now need to go up into the attic and pull all this slack up into the attic just to get this a lot closer to the wall, because with this here there'd be no way I'd be able to push all that slack up into the wall without kinking it really badly. So I'm going to run up into the attic and get this pulled up into the wall. Okay, so that's all the slack pulled up into the attic, so that's a lot closer to the wall. Of course you could very easily pull that down if you ever needed it off again, but it's nice to have all the slack up in the attic so you don't need to kind of worry about loads of slack bunching up in the wall. So let's get this screwed back and get the faceplate clicked on. So now with that screwed back, all we need to do is clip on the front plate. So when you do this, you don't want to screw this plate back too tightly because sometimes it'll then bend and then you can't clip the front plate on with these screwless ones. So it's screwed back reasonably tightly, but not too tight to bend it, and then we can clip the front on. You also might need to play about with the modules. These kind of want to slip about and go to different angles because the cutout in the back plate is bigger than the cutout in the front. So you sometimes need to wiggle a little bit to get it all in, but hopefully we can just clip this plate on. So there we go. That actually went on pretty easily. So there we go. That's the front plate now installed. So as you can see, that's faceplate now on there. And now it's time to label it. What I really like about these modules is they've actually got these little clip out windows, these little plastic windows that you can open it up, pop out the little plastic cover, and then behind that is a little bit of paper that you can use to label it. Now, of course you could very simply just write on this label and stick it back in and put a bit of plastic over. I don't really like doing that, it doesn't look that neat. The other option you can do though, if you don't even have any kind of equipment at all, you just have a normal printer, is you can very easily use the table tool in Microsoft Word, print out a table with precisely sized labels, and just cut them out from a bit of A4 paper and stick them in there. But because I have these black modules, what I would rather do is have a black background with white text rather than a white label with black text, just because it'll be a bit more discreet. So for that, I'm going to use my Brother label printer again. So For this, I have this tape here, which is white on black. And as you can see, it's 9mm wide. And that's round about the same size as the label that came out of the faceplate. So what we'll do is we'll swap this into the label printer. So for some reason I'm going to try and do this one-handed rather than just putting the camera down. Don't know why. Take that label out, put that tape in there, get the back on. And if we turn the label printer on, we'll see it's already set up with the labels that I've created before to do the cable wrap with. So all I need to do now is, rather than having it in cable wrap mode, put it to faceplate mode, and then set the label length to 18mm. And that's because I've measured this little piece of paper that comes out, and that's 18mm wide. So with that set to 18mm, we can then hit print. And there we go, that's the label with both of those designations printed on them. And if you've already seen my video about this label printer before, you'll have seen how this works. And what it actually does is it kind of half cuts each of these labels. So it puts a little cut just through the front plate paper, but not the backing tape for each of the labels. So you can very easily separate them, you don't need to manually cut them. Now at this point what you could do is peel that label off and just stick it inside here. But personally I don't really see the point of sticking it in because there's already that bit of plastic that keeps the label in place. And if you stick it in, it just makes it harder to remove or change later. So instead what I find works is actually with these labels, because of the way they're half cut, you can actually just basically pull them and they'll just tear apart from each other and separate. So as you can see, we have the label there and it's not sticky on the back, it's still got the backing paper on it, but that will perfectly well sit inside that faceplate there. So put that on there, find the little plastic cover, which of course is a clear bit of plastic that is dropped onto the floor, so no idea where that's gone, so I'll try and find that and then we'll clip it in. There we go, I've located a little bit of plastic that will just push that label nicely in, take a bit of plastic, clip it in, and there we go, that's that point labelled. So now time to label the other one, and then this point will be done. And there we go, that's that faceplate now installed and all labelled up. And that looks really, really nice. So yeah, I've kind of glossed over all the features of this label maker here, but if you're interested in seeing more details about this, I've made a dedicated video on this because this thing is absolutely fantastic for networking. But yeah, that's our first faceplate now installed. So what I'll do now is I'll go away, start terminating more of these, and I'll kind of jump in with a couple of little more points as and when I terminate slightly different network faceplates to this one. But you saw how much of a pain that was to terminate this one. Time to do that a lot more times. Okay, so we're getting on with this. I'm now doing a TV point. So as you can see, we've already got the Keystone jacks put on. So now we need to do the coax connection for the TV. So to do this, what I've done is I've stripped the coax back. So what I've done is I've stripped back, obviously, the inner core, so it's got a little bit sticking out in there, and then the outer shielding is sort of exposed there, just stripped back like that. And then with the connector, this is the type of module I've gone for now. These modules are all different, so they'll all have different strip lengths and how you prepare the cable. This one is kind of printed on the back. So inside here what you have is you have a little screw in there, and that's attached to a little post. You can maybe just about make out a little vertical post in there, and that has a tiny little hole on the side of it. So what you need to do is insert the inner wire out of the coax into that little post in the middle there, screw that screw down to tighten onto the inner core, close the outer jacket or the outer enclosure. That then has this piece here that will clamp down onto the shield, and then screw that shut. The only thing I've found is with that screw there, you need to be very, very careful with it. It's not like these sorts of connectors, some of them that have PCBs in them, where there's like a metal plate that screws down onto the wire. With that, it's the screw itself that screws directly down onto the inner wire out of the coax, which is very thin. So I found that if you're not careful and you screw down at all tight, it'll just cut through the inner wire and break off. So you kind of need to screw it down just to sort of nip it up tight enough, just to catch it and no more. And as you can see, you can maybe see it better there because the shield's fallen out and fallen in the bin, so I'll only try and rake that out. So time to get this all put on, and we'll have the coax connection done. There we go, so that's the coax cable now in there. The screw's just nipped up just tight enough to hold it so it doesn't pull out. And what we now do is close this jack over, screw those screws down, and that'll clamp down onto the outer shielding, and we'll have a finished coax connection. And there we go, that's the TV point now installed. Now the other thing you'll notice here behind the TV, I've got 4 modules in a single 2-gang back box. And as I mentioned earlier, these back boxes are a bit tricky for this sort of situation. Because as standard, all you get on these back boxes, these dry lining boxes, is just a little knockout like that in the top. And that's just not big enough to fit 4 of these cables in. For something like a socket, which is what these things are designed for, this design is absolutely fine because you'll have maybe a couple of twin and earth cables, maybe 3 coming in, and then it being stripped right back to the back of the box, and then the inner wires will just be bent around neatly inside the box and into the accessory. But when it comes to data cables, it's a bit different because each cable needs to go directly into a module, and you're keeping the outer shielding or outer insulation all the way to the module. So they're not nearly as flexible, they don't really bend around, and things like network cables, you really shouldn't kink them beyond their bend radius because that can cause crosstalk issues. So if you try and fit, say, 4 cables like this through this hole, you're going to have a bad time. Now, I have done it before with Cat6. When I wired my flat, I didn't think of this, and I did force all the Cat6 cables through the single hole. And you could do it, and they did kind of bend round okay. It wasn't a huge issue. But as soon as we're dealing with thicker cables like this, like Cat6A, these will just literally not bend properly if you put them through that single hole. So instead what I've been doing is drilling additional holes into the top of the back boxes. So as you can see, what I've done here is I've drilled a pair of 20mm holes either side of the middle hole. That way I can feed the 2 middle cables for the middle modules through the middle hole, the existing hole, and then feed the outer wires or outer cables through the 2 new holes I've made. And to do this, all I've been doing is using this step cutter or cone cutter, whatever you'd call it. That works really, really well for making those holes, much easier than the hole saw. So just using a cone cutter like that, just to drill those holes into the back box. There's back boxes that look like that. And as you can see there, if you look up inside that box there, you can see we have the outer 2 cables are coming through those new holes. And that makes life so much easier because when I pull these cables up into the attic and put the faceplate on, all the wires or all the cables will come basically straight up from their respective modules and into the wall. They don't need to bend around inside the back box at all. So would definitely recommend that if you're installing any kind of Euro module faceplates. Just don't be afraid to drill additional holes into the back box just to make your life a lot easier. And there we go, that's all now installed and labelled up. So yeah, that all works there. And this also really demonstrates what I was saying about the different colours of Euro modules and electrical accessories. So these are obviously XL Euro modules in a click mode faceplate. And then this is a click aerial module. So you can see the aerial module matches the faceplate reasonably well, but these XL modules are significantly whiter than the faceplate. Even though Click brand this colour as polar white, generally when I think of polar things, I think of things that are generally quite white. It's actually grey in comparison to these white modules. Now, I knew this would be the case. It's going to go behind a TV, so I don't really care. But it is just important to bear in mind that if you are going to have white accessories on show, you need to watch the colours of white because they can be very, very different between brands. But yeah, not going to bother me because it's behind the TV, and if I was to ever take the TV off the wall and have this on show, I'd probably replace it with a nicer faceplate anyway, but it's just something important to bear in mind. But yeah, that's now the first TV point in. You can also hear I've still need to install double socket. I've been looking into doing that and figuring it all out. Realistically, with the amount of additional sockets and electrical stuff I'm going to need to install upstairs, I'm probably going to look into some sort of way to extend the ring up into the attic, because currently the ring runs around under the floor, get it up into the attic and then drop that down into all the various TV points and other sockets I need to install. So I'll do that in the future, that's a future me's problem. But yeah, that's the aerial point now installed. Okay, so now I'm terminating another one, this time in my studio, but this is where we're going to need to use a metal back box. Because as you can see here, there's this bit of red behind here. That is a piece of wood. For some reason, they've sort of spray painted red wherever battens were for sockets and stuff. It's presumably a signal for someone to cut the plasterboard out or whatever. But this bit red here is a bit of wood. And this is used to mount the socket to. So there's a bit of wooden batten that goes across here between the 2 studs. And then this socket is using a metal back box that's screwed to this batten. It's interesting because on some of the accessories they've done this, and then on others they're just using dry lining boxes, and it kind of seems to be a bit at random as to which they've done. It's maybe a bit more like stuff on the external walls like this are all using these battens, but then the internal walls, some use battens, some use dry lining. Don't know the reasoning for it. But yeah, that's what they've done here. So with this, we've got a wooden batten in here. And what this means is that a dry lining box won't fit. You could probably fit a shallower dry lining box, like a 35mm box, but a 47mm box like the one I'm trying to use won't fit because it'll hit this box here and stick out a little bit proud. So what we'll need to do here is use a metal box. So obviously fairly simple, get a metal back box. So this is a 35mm box. It will sit a bit deeper into the wall though, so I'll probably have about 40mm of space, which is just about enough to work with. So it's a 35mm box. And the reason I'm filming this bit here is just to demonstrate again getting cables into these boxes. Don't do what you do with a socket, is where you knock out one hole, put one grommet in and feed both cables through it. With this, knock out both holes in the top, feed the cables in the same order as you're going to do them into the Euro module faceplates, and then screw that back, and then have each cable going through its own hole. Same also applies if you're to use a 2-gang box to say have a 4-module faceplate. Again, these 2-gang boxes tend to have 4 knockouts on the top. Knock out all 4 of them, put 4 grommets in, and bring each cable through its own hole. And you'll just have a much easier life to get it all installed. So yeah, time to get this box in, get this all terminated, and get another point installed. And there we go, that's all now terminated, and all the slacks pulled back up into the wall. So we can see, going through those 2 grommets, that'll fit perfectly fine when it'll sit nice and flush back. So yeah, time to get it screwed back. And there we go, that's now completed. So we have another completed data point. And I really need to change that socket to match because that looks ridiculous. But yeah, another one down, loads more to go. Okay, so we've terminated more of the runs, and the next area we're going to work on is the living room media panel. So as I mentioned at the start of the video, while I did initially plan on replacing this with a Click branded media panel to match all the other accessories, due to the size of the back box being smaller on the Click one and then needing to patch plasterboard and all that sort of stuff, I'm not going to do that. I'm just going to put the original back box back in, and rather than putting the plastic media panel on, I've got this Dita branded one that'll fit the original back box, so it'll look a bit nicer but still fit on the original back box. So in terms of the back box, as you can see on the back here, these back boxes have basically 2 knockouts for the media panel, for the data point area. So on here you've got sort of a divider in the middle, separate the mains from the low voltage side of things. And in the low voltage area we have a 25mm knockout and a 20mm knockout. So it's going to be a bit awkward trying to get all the cables down here. What I'm going to do is, on this media panel, there's 2 rows of 3 modules. So what I'll do is I'll put my network modules, and 3 of them down the bottom, which gives enough space in here for the cables to bend round. And then I'll put the 4th network module in the top row, directly below one of the knockouts, so the cable can come straight into it. Now the other 2 modules that will be going on here will be the RCA module for the sub and the TV aerial module. We then have all the speaker cables. These aren't going to go into the media panel. Those are going to come down the back here and go to a separate faceplate below with all the speaker connections on it. So I won't need to worry about the speaker connections on the media panel anyway. So it's time to get the back box in and start terminating all these. Cool, so there we go. I've put the back box in, now connected everything up. So we've now got all the Euro modules on for the 6 Cat6A runs. TV aerial points also connected. And then for the sub, as I just demonstrated earlier, the RCA Euro modules I've got terminating an F plug at the back. So I've crimped an F plug onto the coax here. I'll demonstrate how to crimp these later. I'll do all the TV aerials up in the attic and demonstrate that. And then because this sticking at the back would be too much, too deep for the box, I've just put a right angled adapter on here. So that is the RCA connection for the sub. Probably completely overkill, but for a line level audio signal. But with this, I really want to avoid any sort of chance of interference. So I'd rather go overkill than try and cheap out on this and end up with interference. And then below here, we've got all the speaker cables just coming out another back box, so I'll put the other plate on there. So what I now need to do is try and get the media panel on. So get all these modules into the media panel, get the power cables connected up to it, and see if I can get this back on the wall, because it's going to be very tight with all these cables kind of running around the back box, so we'll need to see. It was so tight, in fact, that I couldn't actually get the sub connection through the 2 holes on top. I had to bring it in the side, which works fine, but yeah. It's going to be tight, but hopefully we'll get it on the wall fine. And there we go, that's now all installed. So, yep, that's now on the walls. We've now got the 4 network points, the aerial, and then the RCA connection for the sub. Definitely not a fan of these media panel things. It's just a bit of a pain to put back on the wall, because compared to like 4 separate accessories, which you can screw back individually, with this you're trying to screw one plate back that's got 2 twin and earths, 4 Cat6As and 2 coaxes in it, and try and get that entire thing to screw flush back to the wall without kinking any of the cables. But it's on there now. And to be honest, I'm glad I went for that Dita one. To be honest, it doesn't look too different to the Click accessories. It's a similar shade of stainless steel. And yeah, that looks absolutely fine. It definitely was a lot cheaper than trying to buy the Click one and change the back box out and all that sort of stuff. So yeah, that's now on the wall. So what we now need to do is terminate all the speaker runs. So all the cables are sticking out the wall there. I've already pulled a fair bit of the slack up into the ceiling, so there's a lot more slack on those cables than you can see there. So there's plenty of slack for future maintenance. And then what I've also done is I've made up the speaker plate. So I've taken that Speakon plate I showed before, mounted 3 Speakon connectors in it, and I've labelled them all up. So from rack, ceiling and rear, so that's the channels. So I just need to connect those speaker cables into the back of this plate and screw it back to the wall. I'll see how I feel about this thing. I mean, obviously this one's scratched anyway, so I do need to replace it with a non-scratched one. Maybe this is a bit too sort of industrial looking for the living room. I'll have a think. I'll put it on because it's what I've got and see how I get on with it. If I decide not to go for this, what I would probably end up doing would be replace this with a 4-gang Euro module plate and try and get 4 Euro modules that each have 3 speaker binding posts. I know they exist because I use them in my flat, but the place I bought those from doesn't seem to sell them now. They only sell posts with Euro modules with 2 binding posts. But if I can find ones that have 3 binding posts, I could get a 4-gang Euro module plate there that would match all the accessories better, sort of screwless stainless steel thing, and have basically 6 binding posts, and that would be enough. But I'll have a think. This will do for now. So yeah, time to get this on the wall. And there we go, that's now installed. It looks pretty decent actually, I'm fairly happy with how that looks, but I'll have a think long term as to whether I want to use this or swap it out for some binding posts. But yeah, that's pretty easy to terminate, and that's now the living room media panel sorted. So the final point we need to do in the living room is this point behind the couch. And on here we have a 4-core speaker cable, and that's going to go to a pair of binding post modules for the rear speakers, and then another coax that goes all the way back to the media panel, so we'll be putting another RCA module on that and using that for the sub. So to do the binding post modules, as you can see, I've labelled them up, rear left and rear right. So all I need to do is strip back this speaker cable, put 2 of the cores into one, 2 of the cores into the other, and these all go back to a Speakon jack on that plate we took a look at earlier. And then like before within the media panel, for the sub, we're going to terminate this in an F plug and connect the F plug via a right-angled adapter onto the back of the RCA module. And I thought that at this point I'll demonstrate how I'm putting these F plugs on, because most of these are going to be up in the attic to do it for the TV aerial amplifier, and it's just going to be a bit of a pain to try and film in the attic, so I thought I'd rather do that here where I'm on the ground, it'll be much easier to film. So previously when I wired my flat, I just used what were kind of called screw-on F connectors, where you strip the coax back, take the outer sheath, pull, or the outer shielding, pull the shielding over the outer insulation, and then just screw the connector on. And to be honest, they worked absolutely fine for many years, but lots of people in the comments got really passionately upset about using those and said that I really should use compression F connectors. Now, in fairness, the screw-on ones did work fine, and in the case of this one, it's line level audio, and the TV stuff I'm installing is all just over-the-air TV. There's no cable TV or broadband or anything like that, so it's probably not super sensitive, but I thought I'd buy one of these compression F plug kits because they're pretty cheap, and actually after using these are a much nicer experience to use. And it's one of those things that it's one of those just cheap Amazon kits, so I think this was £15 and it came with the stripper, the crimper and a bunch of connectors, so fairly inexpensive to do it. So to put these connectors on, we've got the coax here. So the first thing you need to do is strip the outer shielding and insulation back. So it came with this neat little stripper. So this will actually do both at once, so you need to potentially adjust the blades here, it's all in the instructions it comes with. Put that over the coax like that there, roughly like that, and then just rotate it round the cable a couple of times and then pull off. And there we go, that's now stripped the coax back. Now I've noticed with this particular stripper that when you do that, sometimes one of the strands of the outer shielding gets wrapped around the inner core, which obviously you don't want. So I'm just going to quickly try and tidy that up, make sure there's absolutely none of this outer shielding touching that inner core, and then we'll come back. There we go, so that's all now prepared. So I've just basically pulled all the shielding back and made sure it's completely clear of this inner core. All we now need to do is take one of the connectors and then just put it over that cable and then kind of just slide it down the cable. I find it helps maybe turn it a little bit, just so that the cable is pushed completely down into the connector and the inner core is protruding from the end. So kind of gently twist it, just work it down. I'm sure there's a bunch of cable TV installers screaming at me right now for doing this wrong, but this is the way I'm finding works to do it. I find it's a little bit tight. I mean, there's potentially different types of connectors for cable, although this is apparently the right type of connector for this sort of cable, but it's a little bit stiff, but it does go down. There we go, you see it's now starting to come through on the end there. And there we go, so that's the connector now inserted onto the end of the cable. So now we need to take the tool, and it's dead easy to use. All we do is take the end of the connector, and then the inner core is going to push into this little guide on here. So we're going to basically essentially line the connector up, there's the tool, and then just squeeze it down. Squeeze like that, and now that is the F plug installed. So that is dead easy to do, and the end result feels like a really nice, good quality connector. Definitely a pretty good option. So yeah, that's the F plug installed. So all I need to do now is get the rest of this faceplate installed. And there we go, that's all terminated. So we've got the F plug into the angled adapter, into the RCA port, and then the speaker binding posts are wired into the 4-core cable. And there we go, that's that now installed. So now we've got the connections for the 2 surround channels and the sub behind the couch. So there we go. That was a look at terminating all the various network points around the house. Now, as mentioned at the start of this video, my original plan was to get the rack fully set up in this video, but that is just not going to happen. As you can see, I've started terminating some of the Keystone jacks at the rack end, but I've worked out it takes me about 7 minutes, 6-7 minutes to terminate each of these. There's several hours of work here just purely terminating Keystone jacks, so I'm not going to do that in this video. So what I'll do is we'll wrap this video up now, then in the time between this video and the next video, I'll go away, start terminating all these Keystone jacks, or finish terminating these Keystone jacks, get all the boring stuff out of the way, and then in the next video we'll have the fun task of actually getting the rack all set up. So we'll get all the bonding installed, get the patch panels installed, get all the active network equipment installed, and get the whole rack fully set up. So definitely looking forward to doing that and finally having an operational home network. But that's it for this video, so all that's left to say now is thank you very much for watching.